Today I'm printing some more aluminum.
I'm going to go ahead and clean the crucible out, and I'm going to then debind and sinter these cubes. Nothing too impressive, but they should give a good measurement of shrinkage. Once I debind and sinter these, send them up to the virtual foundry for inspection under the microscope. Just like normal, I've sprinkled some zinc putty around here, and I'm going to place these cubes into the crucible. I'll be shaking this and making sure that they're tamped down so that they are well supported. Alright, because I have already proven that it works in the microwave, I'm going to just go ahead and debind these in the standard kiln. That'll be a little less maintenance, and just so you see, I did pat these down here just with a cup, and that's going to keep them supported. So tomorrow I'm going to go ahead and sinter these parts and get them sent over to the virtual foundry. We just finished up the sintering process here. We've used all 3 microwaves, and the top glass actually blew up. Yeah, see, it actually just blew up. Some glass even way back there. Here's an interesting peek of inside the crucible after I pulled out the element. Also, just to show, the cubes actually stuck to the element. I pulled this straight out and they stuck right to it. So this clumping of ballast came right out of the crucible. Yeah, okay, those are actually pretty stuck on there. After excavating here, one of these cubes did end up fracturing after I chiseled it out with a hammer and a screwdriver. This gives me a good opportunity to see some of the properties of this. The other 2 cubes I have still sitting over by the crucible. I may end up double sintering those to see if we get some better results. This cube test was actually very illuminating because when I broke it open, as you can see, there's a lot of aluminum powder here. Well, the outside itself is sintered, but the inside is powdery. So this tells me, and I don't know if you can see this, but there is a very defined line of where the sintering has taken place versus the unsintered powder still. So to me, I think what we're going to do is double sinter the remaining cubes and sacrifice one of these other pieces here, cut it open, and then see if we get better results for a complete sinter. But we have the double sintered aluminum cubes. As you can see, this one in particular came out not so great, and a bit of pitting here on the top. I'm going to cut this open. This one seems pretty intact. I'm going to try to keep this one here while I sacrifice this one for some science. Got this locked in, and I'm going to just use a jeweler's saw to cut this in half. Okay, so compared to the first cube over here, as you can see, not fully sintered. How did this second sintering do? As you can see, there is a clear metallic grain even on the center after cutting. This is definitely better. Yeah, this is a good bit better than the first attempt, which is promising. How did we actually do with this? This being the final cube here seems to be the best. I barely scraped this one off. Going to see if we had any shrinkage, and if so, what that would be. These were 20mm cubes. In the X, we had 19mm. We had 18mm in the Z. The Z should shrink a little bit more. And 19 in the Y. So 19, 19 for X and Y, and 18 for Z. So that is actually a very reasonable amount of shrinkage for this cube, potentially because of some alloying that may be occurring with the zinc. As you can hear, this is quite metal. I'm going to do another batch of these so that we can send these off and have them inspected.